Hello and welcome back. In this video we discuss the concepts, static, dynamic, stagnation, and total pressures. Earlier in video 21, we discussed about piezometers that are used for static pressure measurements. It is a simple tube connected to a location where fluid pressure needs to be measured. To measure static pressure at a given location inside a flowing fluid, a static pressure probe as shown in the figure can be used. It is a tube with holes exposed to the flowing fluid as shown in the figure. Connecting this tube to a manometer or mechanical gauge, the static pressure can be measured. Note that a static probe doesn't have an opening at the front end of the probe facing the flow. Consider another arrangement for pressure measurement. A tube called pitot tube is placed in the flow field with tube axis aligned with the flow direction. In this case the tube has an opening at the front and no holes sideways. In this case, fluid enters the pitot tube and fills it up. Since the pitot tube is connected to a mechanical gauge, fluid will not flow through it. Therefore, at equilibrium, fluid particles brought to rest at the entrance of the tube. Fluid is said to be stagnant at the entrance of the tube, and the corresponding pressure measured by the tube is called stagnation pressure. The arrangement discussed for static and stagnation pressure measurement can be combined to a single device, called a pitot static tube. A simple configuration of a pitot static tube is shown in the figure. It combines static and stagnation pressure measurement capabilities. Using such a probe in a flow field, we can measure stagnation and static pressures at a given location of the flow. By measuring these two, the flow velocity at that location can be calculated. Consider a pitot static tube placed in a flow field. Consider the movement of a fluid particle along a streamline from location 1 to location 2 as shown in figure. The flow is assumed steady, inviscid and incompressible. Using Bernoulli equation, we can find an expression for velocity v1 in terms of stagnation pressure, static pressure and fluid density. At P2, the pressure is P stag. Assume there is no static pressure loss between 1 and 2. Therefore the P static measured will be same as P1. Also the elevation at 1 and 2 are same. We know that the particle brought to rest at 2. Therefore the Bernoulli equation can be simplified to solve for the velocity at 1, v1. Consider again the relation we have derived connecting stagnation pressure, static pressure, density and velocity. The stagnation pressure equals the static pressure and half ρ v square. The term half ρ v square is called dynamic pressure. Finally, let us discuss about the concept of total pressure. Total pressure at a given location of a flowing fluid is sum of static, dynamic and its potential head due to elevation. A pitot static tube is used for measuring velocity of a steady, inviscid airflow. The total pressure reads 20 Pascal and static pressure reads 10 Pascal. Calculate velocity of flow. We can use the pitot static equation to solve this problem. The velocity is calculated as 4.4 meter per second. Consider another problem. A pitot static tube is used for measuring velocity of a steady, inviscid airflow at an elevation of 5 meters. The stagnation pressure reads 30 Pascal and static pressure reads 15 Pascal. Calculate velocity of flow. Also calculate the dynamic pressure and total pressure at that location. We can use the pitot static equation to solve this problem. Using velocity, the dynamic pressure can be calculated. Finally, the total pressure can be calculated as the sum of stagnation, static and potential head. A pitot static tube is used for measuring velocity of a steady, inviscid airflow. This device is connected to a U-tube manometer as shown in figure. The manometric fluid is water. When this pitot static tube is placed in the flow, 1 cm difference in manometric fluid is noted. Calculate velocity of air at location 1.